Hi guys, and welcome to my first tutorial. Today we will be covering a few commands or coding commands for SQL, and let's go. The first thing we will be doing here is we will start a program called SQL Microsoft SQL Server Management Studio. It's actually Microsoft product client that will allow us to get connected to my SQL Server. I have my instance here called SQL Learning, and this is just my NT login. So the moment I will hit connect, we will see on the left side under the Object Explorer screen all the server informations and what kind of databases I'll be connecting to. So let's do that. Alright, so now I'm connected to my server and I can start writing codes, running queries, do whatever I want to do actually with the server. Okay, so this is what actually we did cover in the previous prereq video, where I did actually show all the databases, the tables within those databases, the schemas, if you remember from the previous video. If this is the first time that you guys join this channel, I will leave actually a link for the prereq video in the description of this video. And from here we go from the tables, we can see what columns this table has. Okay, so the first thing to prepare our code editor, we will need to do what we need to do is to click on this new query tool over here. Alrighty, now we are ready to start coding or building queries. Right now we will be actually building queries and go over some commands that actually will help you learn SQL. We will start using the first command actually that we will be going over. It's called select, and the select statement actually is used to select data from a database. And let's see how we can apply it. First thing you will do is you will write the command select, then you put a star, go back to the line, and you need to specify your source table, which table we will be using to query our data from. So in this case I will be using this table, the employee table. And in order to specify that table here, I need to write the whole path where that table is located at. So in this case, I need to specify the database in which this table is actually located at. That database is actually AdventureWorks 2009, so I have to specify that. Okay, then you put actually a dot to separate the database name from the schema, which is human resources. Okay, then you have to put another dot to separate the schema from the table name. So as you can see here, my IntelliSense automatically, once I specify the path and the schema, automatically will tell me all the tables that exist within this schema. So I can either start writing the table name, or if I see it as part of the list, I can just double click it. Now I have my query ready for execution, and in order to execute this query there are two options. Either you click on this button here that says execute, or you click on the F5 on your keyboard. So once we do that, we will see the results at the bottom here in this area. and right here. Okay, so let's do that. Alrighty, so now we can see all the results based on the query that we wrote here on the top, and these results are actually saved in some kind of memory table or temporary table, which is called result set. So the moment I close this screen here, all this data actually, or these results will be actually lost until I run the query again. Then you will see those rows here in the result set again. So pretty much this area here, it's called result set, and what it has actually is all the rows that are returned based on the query that you wrote in the top over here. Okay, so this is actually the first way how to write a select statement, and this star over here that I placed, it actually represents every single column from the employee table. So as you can see, it has like several columns. We can keep scrolling until the end. So this is the last column within the table. Now if I want to verify if these columns really exist in this employee table, what I can do is I go to under the Object Explorer here and expand the employee table, then go under columns and expand it as well. And the moment you do that, you will see these columns in the same order as your result sets here. So we have business entity ID, we have national ID number, which is here, a login ID, and so on. So now with this select statement, let's say I don't want to see all these columns. Like for example, this column doesn't make any sense to me because it's just some kind of code or hashed information that I don't want, that I'm not gonna know what it is. So let's say I just wanna return just these three columns. If you wanna do that, you can, and the way to do it is you have to literally write the name of each column and separate it with comma, then type in the second column you want to see and put a comma again, and put your last column that you want to see. Now if I execute this query here, I will not get back all these results or all these columns. I will only get those three columns here because that's what I specified within my query. So let's try that. Okay, as you can see, I'm not getting all the columns that I get within the previous query. Okay, so this is another way how to write your SQL statement. Now let's go over the select top. The select top is used actually to specify the number of record to return within your query. And the way to do that is you write your query as you normally do it, select, and you have to add top and specify how many rows you want to return. In this case we will be using 5, and we will use star to return all the columns from our source table, which is our employees table. Let's run this query and see what the result will look like. As you can see in the bottom screen here, that the total of rows that were returned is 5, which corresponds to the number that we used here in our select top statement. Now let's change this to number 2, for example, and run our query. When you do that, you always going to receive the total results or row results as that number that you keep playing with here. Let's do, for example, 7, and we get 7 rows. So now let's say I don't want to return all these columns. I only want to return the first 3 columns with the number, of course, of rows that I want. In order to do that, you will need actually to remove that star and switch it with the name of columns that you need to return. And let's run our query. As you can see, I still have top 7 rows with only those columns that I specified within my select statement. Now let's change this to 6, just so you can see that the values will keep changing for the total of rows. Let's do 3, and this is how you use your select top. Now let's go over the select distinct statement, which is used to return only distinct different values, meaning if there is a table that has the same exact value across multiple rows and you use your select distinct, you will actually dedupe those values to where you will only show one line or row for that value. Now let's run this query just so I can show you an example. As you can see here, by running this query, I'm getting 290 rows in return, and I have some duplicate rows, like marketing specialist is duplicated across multiple rows. We have this production supervisor, WC60. Actually, yep, it's in here too. The technician as well, it's across multiple rows. If you want to only show one row for each value within your table, you will need to use the select distinct function or command. Let's try that. This is how you write it: select distinct, your column name, and you use your from your source table, and you just hit execute or F5 on your keyboard. Now, as you can see, we just executed this query, and the total of columns is no longer 290 with all those duplicate values. However, it's only 67 rows, because these are distinct, unique values. You will not see anything duplicating here. I'm going to scroll down so you can see for yourself that nothing or no value here is duplicated more than once. Going all the way to row number 67. And this is how you use select distinct to duplicate values within a table. Okay, now let's go over the order by. The order by keyword is used to sort the result set in an ascending or descending order. And the way we do that is we write our query the way we've been writing it, which is select star from our source table, and at the end you will need to write the order by. And when you do that, you need to specify which column do you want to order by or sort by. So in this case, let's see, let's go by the birth date. So let's order by birth date. As you can see right now, we have like everything that we see here. It's not in order or ascending or descending. It's all like mixed values. Let's order by this table. So automatically, I'm sorry, this column, automatically SQL Server, whenever you specify a column in the order by, it will actually default it to an ascending value. So let's try that. As you can see now, the data is sorted by the date or the birth date from the very old date to the most recent date within the table, 1991, and the very old one is in 1951. So when you write it in this way, you can write it in a different way to where it will return the order of these actually rows in a descending order, meaning it will start from the very new value to the oldest value. And the way to do that, you will need to add DESC, which is a short word for descending or descendant. Descending actually order, sorry. So as you can see now, we have the rows sorted in a way that the very or most recent date is showing on the top, and the very old or first value is showing all the way at the bottom. So this is how you actually sort your data when you return it using any of the SQL queries. There is another way how to do it also. Let's say you want to sort by multiple columns. Let's say we will do it by the gender first, then we will sort by the the date of birth column in a descending order, meaning the highest values will be showing on the top and the lowest values will be showing at the bottom. Let's try that. Okay, so as you can see, the first field that we did actually order by was gender in here, and as you can see, all the values here will be F for female until we reach M for male. Then the second column that we are sorting by is the date of birth, which will be this one. So out of all these females, we will do the sorting of the date of birth in a descending order. As you can see, it will go from the most recent date or the newer date going down to the oldest date. So it keeps going down. 1981, 1980, 79, 78, 76, 5, 74, and so on. Now let me show you another way how you can sort these. Now let's go over the where clause, which is used to filter actually records within your results, and it's used to only extract those records that fulfill or meet a specified condition that the user actually add to the query. So let's see how to use the where clause within our query. So we are going to use the same query that we've been using, select star from our employee table, And now let's add the where clause. So let's try first to find only marketing assistant employees within this table. So in order to do that, we have to add our where clause, then add the column actually name, under which we will be conducting our search and implementing this condition. Okay, so now let's run this query, and as you can see, the results only show employees that under the marketing assistant job title. Okay, so now let's try to search by a different column. Let's do, for example, let's search for all the male employees within the company. And in order to do that, we have to use the gender column here. And you can say where the gender actually equal to M for male. As you can see here, all the results are showing for male employees only. Now let's switch that to look for female employees only. Let's run our query, and as you can see, everything that was returned within the results is tied to female employees only. And you can use actually multiple conditions within one query. For example, we want to search for all male employees that were hired on or after January the 1st of 2011. In order to do that, we have to add an additional condition to this where clause, and we have to use the keyword and in order to do that. And hire date is greater than or equal. We have to write it in the same order that we have here. The year, 4 digits, the month, 2 digits, and the day, 2 digits. So 2011 January the 1st. Now if I execute this query here, all the results should be actually for all male employees that were hired on or after January 1st of 2011. Let's run it and see if that's true. As you can see, everything that was returned is for male employees, and everyone here was hired on or after January 1st of 2011. So this is how you use your where clause, and you can add as many conditions as you want. That shouldn't be a problem at all. Now let's go over the and or not. So the where clause can be actually combined with and, or, and not operators. The and or operators are used actually to filter records based on more than one condition. So let's see how we can use that or implement it within one of our queries here. All right, so let's say we will be looking for all employees under the marketing specialist title. So we need to add our where, and our column name should be job title equal to, and let's say marketing specialist. And because it's a string again, we have to put it between single quotes because it's not a whole number or integer. Okay, so now let's run this query for now. As you can see, we have 5 employees under that title of marketing specialist. Now, out of these 5, we only need to return the employees that are single, that are not married. So this is where the operator AND will come in handy, where it will actually help us add another condition. So you will say AND marital status equal to S for single. Now if we run this, we will not get the 5 rows. We should get probably 2, because I only see 2 that are single. Let's try that. Okay, I was right in this case. So now let's switch this to from single to married. M for married. Let's see how many married we have that are marketing specialists. Looks like we have 3 people that are married. Okay, now this is how you use the AND operator. Let's see now how we can use the OR operator. Let's use our generic query here. Alrighty, so let's say we need to look for employees under the, how you call it? Let me see, it was production technician, WC60, that's what it was. Let's say we will be looking for any employee under the job title production technician. So we will do it select star from our source table, which is the employee table, where the job title is equal to production technician W60 C60. Let's run this query. Okay, and as you can see, we have 26 employees under that job title. Alrighty, now let's say we want to return employees within this job title, or any employee whose hire date was on or after January 1st of 2011. In that case, we will need to use the OR operator. And the way we do that is we have to write our query as select star from the employee table, where the job title equal to production technician WC60, or the hire date is greater than or equal, again, the year 2011, the month January, and the day the 1st. So let's write this query. Remember, we had 26 rows in return for the production technician. Now we added an additional condition here for the hire date as an OR, meaning when I execute this query, the result should return for any employee under this title of production technician WC60, or if that employee was hired on or after January 1st 2011. Let's run that query and we will see the results. Alright, so as you can see, now I have 49 rows, which means I have all the employees under the first condition, and anyone who's not under that first condition, which is the production technician WC, these will be actually under the second condition here, because we use the OR operator. And you can see they are all hired on or after January 1st of 2011. And This is how you use the OR operator within your query. Now let's see how we use the NOT. Okay, let's run this query again so we can see all the data from that table of employees. Now we need to return data related to all employees who are not male. So the way to do that is you need to write your query the way we've been writing it. Select star from our source table employee where, and we will write not gender equal M for male. If we execute this query here, all the results that we will get in return will be for all females, because we literally ask SQL to bring us everything from the employee table except employees under the gender M or male. Let's try that. As you can see here, everyone that was returned is female. Now let's change this to F for female, meaning that we are asking SQL Server to return all results from the employee table where the employee is not female. As you can see here, all these employees are not female, they are all male, because we specified to not return anyone under the gender F for female. And this is how we use our operators AND, OR, and NOT. Null values. So what is a null value? It's pretty much a field with a null value is a field with no value at all. Let's see an example here. As you can see on row number 1, we have under the organization node or organization level, we don't see any values here, meaning that these actually cells are empty. There is nothing in them at all. And the way we search or query for null values is we write our SQL statement the way we been writing it again. Select star from our destination table employee, and you will say where organization node is null. Now if I execute this query here, we will see any employee or row where the organization node has a null value in it. Let's try this. Alright, so it looks like we only have one record within the whole table where that column organization node is null. Let's see now if we want to return anything from that table where the value is not null. So the way we do that is we write our where clause and we say organization node, and you type in is not null. Now by doing this, we will select our query and run it, and when we run it, we should not receive any record where this column here, organization node, is null. Let's try this. Alrighty, so I'm going to highlight the column and I will scroll down all the way so you can see that everything that was returned has a value in it. All right, so this is how we use the null values criteria to query any table for null values and non-null values. Aliases. So SQL aliases are used to give a table or a column in a table a temporary name. So aliases are actually usually used to make a column names more readable. Let's go over some examples here so it will make better sense. So the first thing, we will start with column aliases. Alrighty, so let's get our query here. We will always use our employee table for now. Okay. And I suggest when you guys start typing your queries to use this format to make your query more readable. And you will see that actually once we start doing joins, joining multiple tables and trying to return multiple columns, it will make better sense at that time. But for now, try to start writing your queries the way I'm writing it right now, where you do your select command first, then you go back to the line and you do an indent or tab and you type in the first column that you are trying to return, which will be in our case national ID number. Then all the next columns that I'll be writing, they should be aligned within that same first column. So the next one we'll be looking at will be job title, comma, and I will have to write my last column here, which will be the hire date. And as I probably said previously, that in SQL it does not matter whether you write in uppercase or lowercase when you code, because there are some other coding languages like such Python. They actually they are very sensitive when you type in something in uppercase versus lowercase. In SQL, when you code, it does not matter. You can code in uppercase, lowercase, you will still get the same result. And let's demonstrate that right now before we do the alias. So I'm going to run this query in a mix of uppercase and lowercase, and as you can see, I still got my results back. Now I'm going to switch these back to all uppercase and I will run the query. And as you see, it did run again. I'm getting my results. Let's try now lowercase everything. Execute my query, and as you can see, everything is returned back without any problem. Now, going back to our aliases, we will start aliasing columns first. So for example, let's say I did not like the way this column looked like, and I need it to look in different way that will make it actually easy for my eyes whenever I see the column headers. So the way you do that is you have to type in the original name of your column within your table or source table, and you can do the word as, then you can put in the word that you want to see, or whichever name that will make better sense to you for such column. So in my case, I want to display it as national num or number, for example. So as you can see, this is what the column name is stored within the table, but I'm going to display it in this way now. Let me execute this query so you can see it. As you can see now, it has a different name. Now let me make it in a way that will make a side-by-side compare. So this is our original table, and I'm adding an alias to that original table, so the column header or the column name will show in this way instead of this way. I'm going to run this again. So we have our original column name and we have our alias name. Now when you do aliases, or when you use the aliases for columns, you are not renaming the column within the table. You are just using a temporary name until your query is executed, and once you are done with your project, then the original column name will remain within its original name. You will not change that name, just so you know. Now let's practice on changing the job title. So I don't want to see it that way. I need to see it, for example, as job_title. So now we will be moving from this name to the new name, as you can see here. And let me add the original name again, so you get to see the compare. So it's actually stored in the table in this way, but I'm displaying it on my query results in this way, just to make it easy for my eyes to read it better. Now let's try to do the same thing for the hire date. Let's call it a date of hire, for example. DOH. So instead of hire date, I want to see that column name in a different way. Date of hire. Okay. Now you can either use this operator here as, or you can remove it. It will not change anything actually if you do it that way. So let me show you how we can do that. So you just write your original column and you hit the space bar and you put whichever name you want to alias this column with. So I'm going to run it and you will see. So my second one, let me call it number 2 so you guys can see which one I'm talking about. So I call this one number 1 and I have number 1 here, and the second one I called it number 2 and I have number 2 here. So the first one has the word as right prior to the alias number name. The second one does not have the word as prior to it. So you can write it either way. Okay, and we can do the same thing just for the sake of practice on this one as well. Okay, so we have our original column name. We alias it as job title using the operator as. Then we alias it as job title without the operator as. So either way will work for you. Let's do that on the second one as well. I mean the third one. Just for the sake of practicing. You should probably get the point by now, but let's just add an extra example. Okay, so our original column in the table is actually named hire date. We switched it or alias it as date of hire 1 using the operator as, and in another example we alias it as date of hire 2 without the operator as, and it still worked. Okay, hope this will help you actually start using aliases in the event that you have some table with weird names. Sometimes there are too long names that they will occupy actually your result screen when you run your query, and you will have to keep scrolling and scrolling over and over and over to get to the last column. But in this case, when you use all aliases with short names or names that will make more sense to you, you will keep actually the result set area shrinked and more readable. Using comments in SQL. Comments are used actually to explain a section of a SQL statement or queries, or to prevent the execution of your statement or a column within your query. So let's go over the first example, which is explaining a section within a query. Let's say I have this query here, and another query here, so the first query is returning all job titles under the design engineer, and the second query is returning all jobs under the marketing manager title. Now let's say I want to put some comments for each of these queries to explain what this step is doing. In order to do that, you can write /*. As you can see, the moment I typed that, everything turned from its original color to green. So pretty much anything in green while you are writing SQL in Microsoft SQL Server Management Studio, once the code will turn in green, that means you are commenting out that script or that query, and SQL will not run it. It will skip it. So for writing the comment, we'll do /*, then let's type our comment, what this query does actually. That's what we want to explain in this comment. The below query returns all job positions under the, let me copy this one here, under the design engineer title. So this is our comment. Now we have to close our comment. The way to close it, you need to put star and your / again. And as you can see, now if someone sends you a query in a file, once you open it and you see this comment here in the green color, automatically this will explain you what this step is doing. Now for the second step within the code or the script, you just add your comment right above it. So when you share your code with someone, it will make it easy for them to tell what this code is doing. Now, just by looking at this code, it's actually, you will say, oh, why should I use a comment if just by looking at the code I can tell what it's doing? Yes, you can tell what this code is doing. It's because this code has what? 1, 2, 3, 4, 5, 6 rows only. Now, I'm using those short queries just for the sake of this tutorial, but when you get to the field at work, you won't be dealing actually with short queries like this. You will be dealing with queries that are hundreds of lines. Sometimes they get up to 1,000 lines of code, and in order to tell what that query does, you will actually have to go through the whole code, go through all the queries, nested queries. If there are any CTEs in there, you have to read them all and see all the conditions within that code to better understand what does that code actually do. But when you add a comment, a simple comment right before that query, it will actually explain you what does that script do. And so this is actually how to comment a script or a step within a query. So this first step here, this is what it does. This second step of the query, this is what it does. Simple as that. Okay, so this is the first example of putting a comment for a section of query. The second example we will actually use will be for commenting out a part of your query, so we will prevent the execution of that part of the query. Let's use this example again. Now let's say, let me run this query first for you. Let's say I want to comment out one piece of this query so I don't see those results. For example, I don't want to return job title column for now. The way you do that, you do the same thing that I showed you earlier for commenting a section of the script or query. Now we will be commenting out a column within a query. So you do /* then you close your column, your comment by star and / again. Now, what do you think this query will do if I execute it? So pretty much what this query or this comment will do, it will run this whole query and it will skip this line, will not return the job title. So pretty much we will be receiving the national ID number and the hire date only when we run this query. Let's test that. And as you can see, only 2 columns, the ones that are not commented out. Now if I remove the comment that I added and run my query, I will get all my 3 columns back again. And let me show you another way how to comment a column within a script or anything within a script. So instead of putting the / and end it with */, let's use a different way. you can literally use 2 dashes and it will comment out your column here. Let me do that and execute it, and you will see only 2 columns that are not commented. You can also add a comment within your script to explain what that table includes or what it does. For example, let's say I have this table here because it's too long again of a table name. I need to make something here descriptive that will tell me what does that table include. So you can say this table includes employees info, for example. Now, by adding a comment after a table name, as long as that comment has the 2 dashes prior to it, or the / and closed by */, you will be good to go and run it. So let's run this one. As you can see, commenting out a table just to explain what that table has will not have any impact on our results here. Okay. And you can also add a comment to a column name. For example, someone will see national ID number and will not understand what that column actually is for. So you can add in your code here a comment that says this is a unique identifier for all employees. So whenever someone is reading your query, once they see this column name here, they will read the columns that you put right after it, and it will make better sense to them, and it will also tell them where to look for that specific value within other columns, other tables, because in another table this actually column here may be named differently, and without putting a comment to tell the user what the value or what that value behind that column is, it may be kind of difficult for them to find this value within other tables. Okay, so this is how we use comments to explain a section within a query, or to comment out a part of a query or script. Hope this will help. Now let's see the table aliases. So as you can see here, I have this query that I wrote that will actually return all informations from the table employee within the human resources schema under the AdventureWorks 2019 database. So let's execute this query here. Now let's say I only want to return 3 columns from this table. What we can do is we will need to specify the path of that table, then dot and the name of my column, which will be in this case business identity ID, and I need to also return national ID number, and I need to return, let's say, birth date. Let's also add the job title. And run our query. Okay, so as you can see over here, we are actually repeating the name of the table several times and adding it right before the name of each column that we are trying to return. Now, because the length of all these words here and the name of the table, we will actually alias the table name to where we will show it in a short form. So the way you do that is you can, for example, call this table as A. You can say as letter A. Let's run it. Now, because we renamed it as A, the name of this table is not recognizable anymore. And the way to fix that, we will need to switch it from this long name, AdventureWorks 2019 human resources employee. We'll have to switch it to just letter A. Let's switch this one to A as well, and the last one as A. Now, if I run it, the query recognizes the alias A that we specified here as the name of the table that we are pulling this column from. So this is aliasing a table again, which is different from aliasing columns that we saw earlier. Now let's do both aliasing table and aliasing a column all at once now. So this A here, remember, it's an alias for what we call the table. Now let's say I don't want to use A. You may use something, for example, that makes more sense to you, and once your eyes see that word, automatically you will tell, okay, this table is the employee table. Let's call it just EMP, for example, for employee. Then we can switch the A's here to EMP, run our query, and as you can see, everything did run fine. Now let's alias these columns. I don't want to see business entity ID. Let's just alias the column to B for business, E for entity, underscore ID. Let's run it, and as you can see, this word here will change from business entity ID to BE underscore ID right there. Let's do the same thing for national ID number. So from national ID number, it will show as NTNL underscore ID underscore num or number. As you can see here, job title, let's switch it to job underscore title. Now we will move from this word here to this word, job underscore title. Sorry, I had this word selected, and when I executed the query, SQL will not recognize job underscore title as a query. So I have to either select the whole query and run my query, or just click outside the query and hit F5 again or execute. And as you can see, I have job title now changed. Now let's switch date of birth to DOB. This is the original column name, and when I run my query, I will see the column alias now. So this is the difference between alias in a table. You put your alias right after your table name. Then when you call your columns, make sure to put your table alias right before the column, and you can alias also your column name. If you don't want to see it in this way, you can alias it to show in this way. If you are good seeing your column name this way, then you are fine. You can just leave your column as is. You don't need to alias the column. And the reason we did alias this table is in the event that you have multiple tables that you are joining. For example, you join different tables. Let's pretend these tables are different. One is like, for example, sales, the other one is products, for example, and you don't want to be repeating this whole names over and over across all your columns that you are calling. You can just call this like SL for sale, this one PR for product. Then you can just use those aliases right before the column that you are bringing from your from each of those long names or these tables. Okay, we will go actually over joining tables or multiple tables within one of our next tutorials, and you will see how actually aliasing table will come in handy to use whenever you join one or more than one table. In this tutorial, we'll be covering tables, how to create them, how to insert data in those tables, how to modify the data within those tables, and how to delete this data. But before we do that, let's cover again data types. So the first thing that we will be covering is the varchar. I'm going to list it here just so everyone can read it. So pretty much the varchar data type, we use it actually for any column in which we will be inserting an alphanumeric value. So it's a variable length string. It can contain letters and numbers and special characters. The size parameter specifies the maximum column length in characters, can be from 0 to 65,535 characters. The next one we will be going over is integer. The integer data type is used actually for any value that it's in the form of a whole number. In the event, or for example, this number here, or this number here. As you can see, it's a whole number. It does not have any decimals. The next data type that we will be going over is the date data type, which is a date format, and that date format can be in multiple different formats. For example, the year, the month, or the date, or we can put it in a way that the value that's entered it will start with the month first, then the date as a second, and the year in this format. There are too many ways to enter a date format, and we will go over that as well to show you how you can show all those type of formats in the way that you want. The next one that we will go over here, it's going to be the time. The time is pretty much a time format that is entered as 2 digits for the hour, 2 digits for the minutes, and 2 digits for the seconds. Now there are also other time formats where you can add milliseconds as well, and so forth. The next one that we will be going over here will be money, or small money. This data type is usually used for any value that's entered in a form of a currency or money value. For example, $10.99 or $150.89. The next one that we will be going over is going to be the float data type, which is a number used for any value that has decimals. For example, we have 99.95%, or a value that will show anywhere or anywhere near to this, for example. And trust me, you will come across values that will show this way in one of your projects. The next thing that we will be showing here, it's going to be the primary key constraint. The primary key constraint uniquely identifies each record within a table, and the primary keys, they must contain a unique value and cannot contain a null values. Containing a unique value means that if, for example, we enter a value for an employee ID, for example, within a table. Let's say we entered the first employee called Mike. His employee ID is number 1. Then we enter the second record to the table for another employee. The name of that employee is, for example, Maria, and her employee ID, let's say by mistake you enter the same exact employee ID number 1 that you entered for the previous employee. In that case, SQL will tell you that, hey, Mr. User or Miss User, you already entered the value or a record for an employee with that value, number 1. You cannot use that number again. You need to use something else that we don't have or does not exist in that table. That's pretty much what the primary key is used for. And it can also be used to join multiple tables on that value or that column that has the primary key. The next one, constraint that we will explain here, it will be the foreign key. And the foreign key is a key used to link also one table to more tables. And we will go over those joins within a different tutorial once we start covering joining tables. But right now, let's go over creating tables. The create table statement is used to create a new table within a database. Let's create a new table, and in this example we will be creating a table within the database called training. And as you can see here, under the training table list, the only table that exists in there is sales table. We need to create a new table called employees. This is how we will create it. The first thing you will use is the command create table, and you need to specify the name of this table. So we will be calling it employees. Now, by creating this table, after specifying the name, we need to specify the columns that will be inside that table. And those columns, we need to give them or specify data type for each of those columns. The first column that we will be creating here, it will be the employee ID. So since employee ID will be in a form of a whole number, we will give it a data type as an int or integer. Let's use int for now. And because an employee ID should not have a null value in it, or should never be null, we can specify the word here, not null. Now we need to make this column as a primary key. We'll just specify primary key. Now let's go and create the second column. In order to create the second column or add the second column, we need to add a comma in here. Go back to the line and we specify the name of that column. So in this event we will be using first name, and since names can have a string of characters between numbers, letters and numbers, then we can give it a data type as varchar with 50 digits or a length of 50. Next one will be employee last name, and we can give it also a varchar of 50 characters. Then we can use date of birth, here, and in this case it will be in a form of date data type. Then the next one will be the customer's yearly, or sorry, the employee salary, which is the yearly salary. And because it's in a form of a currency, we'll give it a small money. Then you need to close your parentheses that you opened here. And you can also commit your query by adding either a semicolon or the word go. And the reason we use the semicolon or go is literally to commit this this statement here, to tell SQL or to let SQL know that I need you to start the script from this position here, right before the word create, and end it right after the closing parentheses. Now let's run our script and let's see if all those columns will be showing under the employees table. Again, the way we execute our query is by either clicking here on the word or the tool execute, or you can just click on the F5 button on your keyboard. Now I just executed this command or this query, and in my result set screen here, it's actually giving me a message that the query was executed successfully, and it also give you like the completion time, which I don't need at this time. Now what I need to do is to verify within this database if my table was created, yes or no. The way we do that is you go on this table, this database training, you right click it and you click on refresh. Once you click on refresh, you go under tables and expand it again, and you will see that our table was created here. It's called employees, and by default any table that you will create, it will have a schema called DBO automatically and by default, and you can change that in the setting of your SQL server to actually default it to whichever schema that you want. Now let's expand the employees table that we just created to validate that it does have actually all these columns that we created or that we added. Expand it, then expand columns, and you will see the first column is employee ID, and it has a primary key. It's in a data type as int, and it's a not null value. It's the same thing that we gave it here. The second one is the first name, and it's a varchar 50, and we have the same thing here. So SQL by default, if you don't specify null or not null for the column, it will default it to not null, to null actually, which means this column within the table employee may have a null value for such column. So the next one is a last name, and it's showing 50 characters, and it's a varchar, and the same thing here that we entered. Date of birth is set as a date, and that's what we gave it. The yearly salary, we gave it small money, and it's showing the same value here for that data type. Okay. And this is how you create tables and how you specify which data type that will go for which column. Once you create a table, you need to insert data into that table. And in order to do that, there is a command called insert into. And the insert into select statement copies data from one table or from a temporary table and inserts it into another table. But before we insert data into the employees table, let's make sure that we don't have any data in this table. I'm going to execute a select star from the employees table just to see if it has any information in it yet. And as you can see, the table is empty. There is nothing in it, no record. Let's go over the way how we will insert data into this table. The first thing you will need to do is you need to specify the command insert into followed by your destination table, which means which table you want to insert data into. Then I will specify, I need to go by the same order here. Employee ID first, first name second, last name third, date of birth as fourth column, and yearly salary as the last column. So I will specify employee ID number 1 as employee ID. I'm just going to run this so you can see the value that I will enter in the employee table. Then the next thing I need to enter to the table will be a first name. I'm going to choose John as a first name, Doe as last name. The date of birth, I will choose 1990 August the 1st. And remember, when you alias the value that you're going to be enter, make sure to alias it in a word that will be actually exactly as the column name. So SQL will know that this value here should go to the employee ID, and this value here should go to the first name column within the employee table, and so on. So after the date of birth, now we need to enter the yearly salary. Let's say $95,000 per year. Okay, so I can actually end my statement by either a semicolon or the word go, as I did previously here. So let's try it with the semicolon. I'm going to enter this value now into the table, and as you can see, it says 1 row affected. Now let's pull data from the employees table and see if the records were already entered to it or not. Now I'm going to execute my select star from the employees table, and as you can see, the table now has data, and that data is exactly what we specified in our insert statement here. Now we need to insert a second record for a second employee, and this time let's say we want to insert a record for the employee Jessica Smith. She is born on 1980 June 15th. Her salary is $150,000, and I give her employee ID as number 1. So now let's enter the second employee's info or records into the employees table. I'm going to highlight my query and click on execute, and as you can see here, I'm getting an error. For some reason, this table cannot take any information for this employee here, and the reason why, it's telling me that violation of primary key constraint, primary key employee blah 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 cannot insert duplicate key in object DBU employees, which is the table employees. The duplicate key value is 1, which is the value 1 that we entered here. Why? Because we already have an existing employee, John Doe, with that employee ID number 1. So you can't have multiple employees under the same employee ID, because this employee ID should be unique to every single employee within the company. Now let's switch this to number 2 as the employee ID for Jessica Smith. Now let's enter that record to this table by running our query. Now you see that the value was entered and the query did run fine and successfully. I will now pull all the informations from the employees table, and as you can see, we have our second record here. First one for John Doe, second one for Jessica Smith. Okay, so actually I was supposed to put $150,000 for Jessica Smith, but by mistake I entered $15,000, which is okay. This mistake here that me as a user actually committed here, we will see how we can correct it. Now let's try to enter a third record to this table for a third employee. Let's call that employee, for example, Mark Johnson, who was born in 1976 in March 28. His salary is going to be $120,000. I'm going to highlight my query and hit the F5 to execute it. As you can see, our query was successfully run and completed. Now let's run the select star from the employees table so we can see all the records that have been entered into the table. As you can see here, I have John Doe, Jessica Smith, and Mark Johnson entered in the table just like the way we used in our query. Updating a record within a table. In order to do that, we need to use the command update, or the update statement, which is used to modify the existing records in a table. Now, remember I told you that I entered the wrong salary for Jessica Smith? I was supposed to enter $150,000 and I entered $15,000 as her yearly salary. Now, in order to fix that, we will need to create our update statement. The way you do that, you have to write update, and you need to specify the table name, employees, and you do set yearly salary as $150,000, where employee ID equal to for Jessica. As you can see, her employee ID is 2. So right now she's under $15,000 per year. As you can see, 1 5 and 3 zeros. I'm going to switch that from 1530s to 1540s. And we can terminate our code with the semicolon. I'm going to highlight my code because the reason why I highlight it is because I have another statement underneath of it that I don't want to run right now. So let's highlight my query, hit the F5 or execute, and as you can see it says one row affected and our query did run successfully. Now let's run this query so we can return all the records from the employees table and verify if Jessica's salary was corrected from 15,000 to 150,000. And as you can see here, it did go from 15 plus 3 zeros to 15 plus 4 zeros. Here is 1, 2, 3, 4 before the decimals, of course. And this is how you update records. Now let's say I also made a mistake on her date of birth, and instead of June the 16th, or instead of June, let's say the 11th, I entered June 16th. Now I need to modify this from June 16th to June 11th. The way we do that is we write update, the table name, we need to set the date of birth column to 1980 June 11th, where the employee ID equal to, for Jessica, as you can see here, we have June 16th. Once I run my update query, the June 16th value will be switched to June 11th that is specified in my query. Let's test that. Okay, my update query did run fine and completed successfully. Now let's validate if the change happened to the record or no. And as you can see now, her date of birth is no longer June the 20th. I can't remember which date I had in there, but we switched it to June the 11th as we specified in the query. And this is how you update records within a table. Alter column. The alter column statement is used to add, delete, or modify a column in an existing table. Let's say, for example, we have the first name over here as highlighted on the left side of the screen. It's set to a varchar of 50 characters. And let's say we just got a new employee whose name or first name is actually exceeds the 50 digits. Let's say that employee's first name has like for example this long, and the total actually of those digits, let's pretend it's over 50. Once you try to enter that value to the table will actually, or the SQL will give you an error that will tell you that the value that you are entering is way more than 50 characters or digits. You need to enter a value within a maximum of 50 digits for the first name. So let's say we need to change this from 50 to 150. The way we do that is we need to use the alter command. So we have to alter our table, employees, then we have to alter our column first name and switch it from varchar 50 to 150. We end our statement with the semicolon. This one is, you can do it or you can remove it, you don't need it. But the reason you use it is in the event you have multiple scripts, like let's say you want to change the last name as well, and you want to change the salary or the yearly salary from small money to also varchar, and you want to run everything at once, then it's good to have those commit semicolons or the word go. So when Seek will run everything at once, it will run the first statement first, and once it reaches go, it will reset and run the second script. Once it finishes the second script and gets to the word go, it will stop and reset again. This actually helps optimizing the memory of the SQL server, so you don't run everything at once and it will be too much of script for the server's memory. But in this case, we are only using one step or script to update this column from 50 varchar 50 characters or digits to varchar 150. Let's execute this command, and as you can see, the command completed successfully. Now let me refresh this so we can see. As you can see, this 50 is from what we entered earlier. Now after we run this script, we will refresh our column by right-clicking and click on the word refresh, and you can see here the first name changed from 50 digits to 150 as we specified here. And this is how you alter a column or a table by changing the data type actually from one data type to another, or by increasing the data type within the same type that we gave that column. In this event, it used to be varchar, we kept it as a varchar, we just increased it from 50 to 150. The delete statement is used to delete an existing record from a table. So let's say on the table that we have in front of us here, the employees table, let's say we want to delete this last record here because whomever entered this record was not supposed to enter it at all. It was supposed to go to a different company, for example, but they enter it to our employees table. So the way we delete this record is we have to write our delete statement as the command delete from our table employees where the employee ID equal 3, which is the corresponding employee ID for Mark Johnson that we need to delete in this example. Now let's highlight our query and click execute. As you can see, the command was run successfully and it tells us that one row was affected, which means employee ID 3 was deleted. Now let's validate that that record was truly deleted from the table. We will run our select statement with the select star from the employees table, and star again, it represents every single column within the employee table. Just as a reminder. And as you can see now, the employee ID number 3 or Mark was deleted. This is how you delete a record from a table. You just need to make sure to specify which record. If you don't specify where clause from here, then you just run your query just this way, you will lose everything from that table. And at that time you'll be in trouble because you lost company's data and you don't want to do that. You always need to make sure that you are deleting the exact record that you want to delete. And before you run your delete statement, for example, let's say we want to delete Jessica. Make sure to do select star from the employees table where employee ID is 2. Run your select statement first to make sure that this is the record you want to delete. After you make sure that that's the record you want to delete, then you can remove select star and switch it with the word delete. And you run your query and it will delete also Jessica from the table. Now, let's validate that we didn't delete anything because I did not run this query. Okay, so Jessica is still there. Good. This is how you delete a record. Just be super careful whenever you run that command. Always check what you are deleting before you hit the execute button here or F5 on your keyboard, because you may be losing some data that you don't want to lose or you don't want to delete, and it will be deleted by mistake. You don't want to do that. The truncate statement is used to clear a table for all records. Let's say, for example, we have our employees table that has these 2 records here. Let's pretend this table has like millions of records in it. And we want to wipe that table completely and remove everything from it. But we don't want to delete or drop the table from our database. We still want to keep that table in there. The way we do that is you use the truncate statement. I can't type today. Truncate and table. Truncate table and your table name. So our SQL statement here was completed successfully, which means this script was run as it was intended. Now let's verify our table and see if all records were dropped from it or deleted from it or no. So we will select star from employees table. As you can see, everything was dropped from the table. We don't have any records. Why? Because we used the truncate table statement, which allows actually to remove and delete every single record from a table. And this is how you truncate a table. The drop table statement is used to drop or delete an existing table completely from a database. Let's go over how to drop a table from a database. As you can see on the left side of the screen here, within the training database, I have 2 tables. employees table and the sales table. I need to drop the employees table in this case. The way we do that is you do drop table and you specify the name of that table. So drop table employee. Let's run it. Okay. So it's SQL Server is giving me an error telling me that I cannot drop the employee table because this table does not exist or I don't have a permission. So why did I get this message here or error message? It's simply because I misspelled the name of my table. It's supposed to be employees in plural and I put it as employee. So if I add the S and execute my query again, you will see that my command was run successfully. Now let's make sure that this table was deleted completely from my training database. I'm gonna go to the training database here, right click it, click on refresh, then expand the tables folder, and as you can see, the employees table is gone. It does not exist anymore. Why? Because we dropped it completely from the database using the drop table statement. And this is how you drop a table from a database. Again, when it comes to dropping tables, dropping columns from a table, deleting records from a table, anything that has anything to do with deleting or dropping anything, do not just type your query and execute it right away. Always check, double check and triple check your statement before you run it, so you don't lose some data that you really need. Now, when you work in a company, usually that company does a backup on daily basis for their data, but if you drop a table today, you can literally open a ticket with your IT department so they can get you the backup for whatever you dropped. But the thing is, sometimes it will take a few days to get that data back, and let's say you really want to use that data today, then you get stuck without any data. You can't do anything. So please check, double check and triple check your statement before you execute them. Like. The like operator is used in a where clause to search for a specified pattern in a column. Let's use some example here to go over this operator. Okay. This is how we write it. I will write my normal select star statement here. I will choose my table. The table I will be using, it will be the address. Okay, so let's say I need to look for specific value within a column. In this case, I will have to write a where clause starting with the word where. Then I need to specify which column I need to search by. In this case, I'll be using the address ID, and I will pick an address ID, for example. So what I'm asking SQL to do here is to return any data where the address ID is equal to 1, 2, 1203.7. Let's try that and see if there is any record that exists. Okay, so we have one. Now let's say I don't want to see all these columns here. In this case, I need to specify which columns I need to see. So I want the address ID, address ID line 1, address line 2, city, state or province ID, postal code. Let me drag this down so you can see the whole query. Okay, this looks better now. So the way I wrote actually this query is I need to get all the records from the table address that meets or that meet this criteria, and the criteria is the address ID should equal this value 12037. Now I can write this in a different way to where I can eliminate that equal sign or operator, and I can switch it with the operator like. And if I run it, it should work the same way. Why? Is because we are just asking SQL to return again every single row where the address ID value looks like the value that we entered here, 12037, which is exactly this address ID that we have here. Now, let me show you another way or another example where we use the like. We could use it also in a string, for example. Let's use the address line 1 because it has a string of characters and numbers, or a combination of the two. Now let's say I need to look for any address that includes the word Napa. Okay, so my query here did error out, and the reason why is because I did not include the operator like. Okay, as you can see here, I had 18 rows actually returned, and all these addresses, they include the word Napa. So the first one has 10 Napa Court, 1970 Napa Court. You have Napa Street, Napa Street, and so on. So this is another way where you use the like, is with wildcards. Wildcards is when we specify a value between two words or a string of words or string of characters. We'll go over this these wildcards actually in the next step. Let's do that then. Wildcards. A wildcard character is used to substitute one or more characters in a string. We usually use it within the where clause. Let's go over some examples. going to start building my query as usual. Select start from, need to put schema, the human. Then my table will be employee. Let me see if I type it right. Okay. I need to select my database first. And yes, I've got it right. Now, let me limit the columns just to make this result set here looks clean. Okay, so let's say I only need the business entity ID. I need the login ID, job title, and the birth date. Maybe let's add one more, to gender. Okay, this should be enough. Let me drag this down here so you guys see my query. Now let's use or see how we can use the wildcards in here. Let's say I need to look for any job title that starts with the letter A. In this case, I will write where job title, like, remember this is the operator we used in the previous section of this tutorial. Like, then we open our single quote and we say we need everything that starts with the letter A, like Adam. And I will type in my letter A, and I don't care what comes after the A on my results. As long as that job title starts with the letter A, I need to see it as part of my results. So the additional strings that comes after A, I need to replace that with a %sign. Then I need to close my single quotes. Now if I execute my query here at the bottom or within the result set, you will see the job titles in all these actually rows that were returned, which are 13 in total. Everything here starts with the letter A. And since we say we don't care what comes after the A, you will see that there is a C after A, an S after A and their assistants, a P for application, specialist. So there is a P that comes after A. As you can see, there is no consistency on whatever character that comes after A. And why? It's because we said give me everything that starts with A, and we don't care how it ends or what comes after the A. Now, let's say I need to find any job title that ends with the letter T, like Tony. So what we can do here is we need to flip these actually strings. So in this case, I will say I don't care how the string will start, but as long as it ends with a T, I need it as part of my results here. Now let's execute the query and you will see everything here ends with the letter T as Tony. So we have assistant ends with T, specialist ends with T. Pretty much everything here is assistant and specialist. Oh, we have accountant, it starts with T as well. Okay, so this is how we play with the wildcards when it comes to strings or values, how we want them to start, how we want them to end. Or let's try another example here where we will go over a string that we are concerned with that is in the middle of that whole string of characters within a column. Now let's say I need to look for anything that has the value OR in the middle. The way we do that is we need to start our filter here by using the percent sign. Then we can write our OR, then end it with a percent sign again. So the way we read this is I'm asking SQL to return all records where the job title has these two characters in the middle. I don't care how the value of that column starts. I don't care how the value of this column ends. As long as there is a value of equal to OR in the middle of the whole string within the column, then yes, return it. Let's execute it so we can see an example here. Alright, so we are looking for anything that has OR in the middle. This is the whole string. It starts from S all the way to R for designer. And we need to look for anything that has OR between S and R. And we have it here under senior, OR. Hopefully you can see it right here. For the second example, is actually within the same bucket. We have the OR for senior. We have it here also, OR for senior. Now in example number 4, we have it under supervisor. So this is where the OR is. And let's see if we have other actually values down the results here. So this one is also supervisor. So this one is janitor. So we have an OR. Now you're going to tell me, well, OR is at the end of the word, and we say it needs to be in the middle. But again, just to explain it in a very simplified way again, so I need the value. I don't care if the value or what the value starts with, and I don't care what it ends with, as long as actually it has the value OR in it, then bring it in. So in this case it did bring it as at the end of the word, which is okay because we still said I don't care how the word ends. Now let's say I need to look for anything where the second letter is R, like Robert. The way you write that is you type in underscore R for the second character, then a percent sign. The way you read that is I need results from this column where the second letter is an R, and I don't care how that string of characters end, and I don't care how it starts. But as long as the second letter is an R, bring it back. Let's execute it and see some examples here. So the first example we have is production. So the second letter is an R, as you can see right here. Second letter is an R. And Let's see if we have something else other than production. Well, it looks like everything within our database that has a job title where the second letter is an R is actually a production. I can't see anything else, but I hope that this example actually made a better sense. Now, let's go over another example where I love to play with these actually wildcards. The next example we will be looking at here is I need any value that starts with the letter M, like Monica, and ends with the letter T, like Tony. So the way we do that is I need to specify my first letter, then I don't care what happens in the middle of that whole string within that column, as long as my last letter is T, like Tony. Let's execute this query here and go over the results. Okay, so we have marketing assistant. It starts with the letter M in marketing. It ends with the letter T in assistant, right here. And we have another value, marketing specialist. It also starts with the letter M as Monica. It ends with T as a Tony. And this is exactly what we specified in our filter here. So this is how you guys can use the wildcard within your SQL statements. And you can use as many characters as you need within your filters, and just so you know, all the results are depending on the way you write your statement here or filter. Date format. We can write our date actually in SQL in many formats, and the first thing we will do here, let's see how we can determine today's date. So the way you do that in SQL, you have to write your select statement, and today's date is actually corresponding to get date, open parentheses and close parentheses. This is how we look for today's date in a SQL database. Now if I execute this command, and as you can see, I don't have any tables specified in my query here. And the reason I have that done this way is because I'm trying to look for today's date within SQL system, not within SQL database, where I have to look through some tables in order to find that. I'm just going through against the system and saying, give me today's date. Okay, and as you can see, it says today's date, January 22nd, 2021, and the time is 10:43 a.m., which is the morning. Now, as you can see, I did not specify or alias the column name. That's why it did not spit out anything here. And remember the alias in a column from the previous tutorials? This is where it comes handy. So we will call it, for example, today's date. And there you go. Now, let's say I need to actually get the first day of the current month. So we are in January 2021. I need to extract, or actually, sorry, I need to get the first day of this month. In this case, I need to write it this way. Date add M for month, date, def, of the current month. Now I have some stuff here that are underlined. Let's see, what did I type wrong? There should be a comma instead of parentheses. Okay. Now, as you can see, this is today's date, January 22nd. And since I was looking for the current date, the very first date of the current month, it did return January 1st, 2021, which is exactly the very first date of the current month. Now, and you guys don't need to memorize by heart all these syntaxes here. You can always look them up online. For example, let me give you an example here. So if I need to look for that, I just look for SQL first day of previous month. Then you just click on the first result that you will get. Then you can highlight the first query that you will get, come to your management SQL Studio or SQL Server Management Studio and paste it. You can run it, and this one actually is the first day of previous month. Is that what I looked for? It looks like that's what I looked for. Yeah, the previous month. Well, let's say the current month. Okay. So let's specify today's date here. So using today's date, I need to get the first day of that month. The month for which today's date corresponds to is January of 2020. And as you can see, the query returned the very first day of the current month. So that's why you don't need to actually memorize all these syntaxes. Everything is online, and Google will be your friend. So let's say now I need to look for the last day of the current month. The way you do that is you can write end of month from get date plus 0 last day of the current month. And as you can see, it did give me the last day of the current month, which is January 31st. Now, let's say I don't want to see the timestamp within those date results here. The way you can do it, for example, on the first one, which is today's date, I can wrap that command or syntax between a cast. So I will cast it as date, and I will alias it as today's date. So casting it as a date will only bring us this value here, and it will remove the timestamp. We will not see it. Let's try that. As you can see, it's gone. Let's do that for the same column, the second column as well. We'll cast it as date, then we will alias it as first day of current month, so it will show here as a column header. Alrighty. Now we have clean data. Now let's say we want the first day of the previous month and the last day of the previous month. So again, you can always Google it, and just to save some time here, I'm going to just copy and paste it. And as you can see, the previous month is December of 2020, and the first day is December 1st of 2020. Last day of previous month is December 31st. And the same thing here. Let's get rid of the timestamp. You can do cast the whole syntax as a date, and there you go. The timestamp is gone. Let's do that for the last day of previous month as well. And I'm repeating this casting just so you guys get used to it. There you go. The timestamp is gone. Now let's try the next month. So because we are in January 2021, next month, first day will be February the 1st, and the last day will be February 28th of 2021. And because those values are already casted as date, I don't have to add the cast data in here. And let's say now we need to extract each value from a date in a separate column. And the way we do that will be, for example, let me get rid of everything here. I'm going to comment it out so it doesn't return anything. So let's play with today's date only at this moment. Now let's say I need to return the day, the value of the day, which is the 22nd, by itself in its own and dedicated column. The way you do that is you type in day from today's date and alias it as day. So I'm going to write it this way so I can extract just the day in its own column and add it here. Okay, so you see it did actually give us the value of 22, and it did extract it from this whole string of a full date. Now let's say I need to bring in just the month from today's date as month, and the month of January is actually the very first month of the year, so that's why we have the value 1, and it was extracted from here. Now let's say I need the year in its own separate column. The way you do that, same way, get date as a year. So what I suggest, whenever you write a query and your column is in different color other than black, make sure to put it between square brackets. That way, SQL will not take that value or that column header as a function that is built-in to the SQL actually coding. So just you will tell SQL, hey, this is not this command or this syntax or this function or operator. However, it is a column header that needs to be actually telling me what column I'm dealing with. Sometimes there are some commands or operators. They are fine to be within a column actually header, even if you don't put the square bracket. But sometimes there are some actually that they can't be taken. I can't remember which ones. Let me see. There are some actually that cannot be taken as a column header. For example, plan, I guess. Yeah. As you can see, in order to call that column as a plan, I need to wrap it between square brackets. So, however, this is not a plan, but it's a year. Okay. Now, let's say I need to change the format of this date from whatever format you're looking at right here to where I will see the 2 digits for the month, 2 digits for the day, 2 digits for the year. In order to do that, we can write convert char, because we will be converting the value from a date to a string. Char get date Yes, alias it also as today's date. So as you can see, we have 2 digits for the month, 2 digits for the date or the day, and 2 digits for the year. So let's call the column this way, so it will make sense to us. That will match the format. Now let's say I want the same format, but now with the 4 digits for the year. The way we do that is we just switch this from 1 to 101. And that will give us the 4. Remember, this has nothing to do with what's going to be returned. It's just the name of the column. This is where everything happened. By changing this number from 1 to 101, we will add 2 digits to this one. And as you can see, it's the same one. It's just that this one has 2 digits for the year, and this one has 4 digits for the year. Now, let's try another value here, or format for the date. Okay. No, I don't want this one. That's pretty much the same one that I had. Okay, 106 it should be. And this time we need it to show 2 digits for the date, 3 digits for the month, and 4 digits for the year. Let's run it, and as you can see, it says 2 digits for the day, 3 digits, which are the first 3 digits of the month, January, and 4 digits for the year. There are so many formats of dates that you can play with. And again, you don't have to remember everything by heart on all these syntaxes. You can always search them on Google or any browser that you may have through any search engine. And the main actually website that I usually use, and again, this is not a sponsored website, it's just one of my favorite websites that I usually use. Okay, if you don't have access to install a SQL Server within your computer, or you don't have a Microsoft SQL Management Studio where you can practice all these syntaxes and codes, you can always go to w3schools.com/SQL or SQL / and you will have pretty much all the commands here. So that's why I keep telling you, you don't have to remember everything that I'm typing or what I'm saying. You can always find everything in Google. Then let's see here. So they have the SQL dates. These are all the crazy formats that we have gone through, and some of them we didn't cover because there are too many actually date formats, and you just keep scrolling, it will tell you how to do it. It will also give you syntaxes. You can also Google multiple formats from different websites. So there is the syntax. It gives you also here the syntax for each of these formats. Let's try this one. Not sure if it's gonna take format, but let's try it. Yeah, it did. Okay, so today is Friday, January 2021. It just didn't have actually what day. Yep. So this is how you play with the date format. And as I said, if you don't know how to write a format or a syntax, if you can't remember it, just use Google, and any website actually will give you the syntax and help you write everything that you need actually. Date difference. Date difference actually is used to calculate the difference between two dates. For example, what's the difference between day 1 and day 2 in days, or what's the difference between day 1 and day 2 in months, like how many months in between, things like that. So let's go over some examples here. Okay, so let's say select star from I need to select my database. So let's go over the employees table. And as usual, I don't want to see all those columns. I only need to see few to make my result set actually look cleaner. Job title, hire date. Okay, so for each of these employees, we have a hire date. Now, let's say I need to know for how many days this employee has been hired for. In order to do that, let me add today's date first. Okay, let me cast this as date. Okay, so today's date is January 22nd of 2021, and this employee here was hired on January 14 of 2009. Now, I need to see the difference between the hire date and today's date in days. So how many days this guy has been hired. All right, in order to do that, we will write date diff, which is date difference, and I need the results to be returned in days, and I need to put my first date here, which is the hire date, and my second date, it will be today's date. And I will alias it as difference in days. So pretty much what I'm asking SQL to do here is to calculate the difference between the hire date and today's date, which is this column and this column, and give me the results here under a column called difference in days in total of days. Like how many days? 3 days, 4 days, 5 days, 2000 days. And as you can see here, this employee here in row 16 has been employed with the company for 4,782 days. This employee was employed actually within the company for 5,000 days, 110. Next one is 3,637 days that he or she has been actually employed for with the company. Now let's say we want to do this in month. You can use the same exact syntax and you just switch from day to months and you alias it in months. So this guy was hired for 144 months within the company. This guy 156 months within the company, and so on. So this is how you calculate the difference between two dates. Type in the date difference. How do you want to see that difference? Is it in days or months? And you put your first column or date column, and then comma your second date column, and you execute your query. Then you will get your results in days, results in months, based on how you wrote your statement. Between. The between operator returns values within a specific or a given range. Let's go over some examples here. Let's write our query. So we will use our employees table again. Specify our columns. Let's do our hire date. Okay, let's run our query now to make this result set clean. Okay, now let's say we want to look for any employees that were hired between a date A and date B. In this case, I will need to go to my where clause and say where the hire date is between, and I can specify the first date as January 1st of 2007 and December 31st of 2007. So you need to say, specifying the where clause, your column under which you are running your filter or your condition. Then you specify the operator between, then your first date, and you have to write the operator and your second date range. Now if I run this query, as you can see here, I have people that were hired in 2009, 7, 2008, 2010, and so on. Now by running this query, everything that gets returned should be between this date and this date. As you can see, everything is within 2007. Now let's say I need to look for people that were hired in 2009 only. Then I can run my query and you will see that everything here is showing that the hire date happened in 2009. Now let's try different date range here. And you can play with these actually dates in the way that you want, or based on the criteria that actually your project is asking for. I'm just using these dates here for the sake of example, so people can actually understand how they can use the between operator in SQL. Alright, so we have everyone here was hired in 2010. So this is how you use the between operator. Let's go over these operators. This is different than, less than or equal, greater than or equal, equal, plus or minus. Let's go over some examples in which we will implement all these actually operators. First thing we will need to do here, let's start building our query. Okay, let's always use our employees table. I keep using this table because it's kind of easy to stick to that one table. Okay. I'm always trying to type my query or write my query in a way that it's more readable. I don't like to keep writing like all the columns in the same row like this. I always like to write each column in its own row. Okay. All right, so now let's say I need to look for all employees that were not hired within a certain day. For example, anyone in January 14th of 2009, I don't want to see those. In order to do that, we need to write our where clause, and we need to specify the column under which we need to apply our condition, and let's say is different than 2009 January 14. So pretty much when I run this query, all the results that will be within this result set here will be for every employee except the ones that were actually, as you can see, employee number 1 was hired on January 14, 2009. So pretty much this employee here will be exempt, or we will not see it as part of the results. Let's run our query. Yep, as you can see, number 1 is gone because we say we don't want to see any employee that was hired on this date, January 1st of 2009. Let's say I don't want to see anyone that was hired in 2007, December the 5th. In this case, employee number 4 should not show. See, we have employee 1, 2, 3, number 4 is gone. We don't see it anymore. Why? Because we literally specified for SQL to not return any employee that was hired on this date, December 5th of 2007. Now, let's go over the less than or equal. Let's say we need to look for all employees that were hired prior to January 1st of 2007. Let's do that. Less than or equal . Okay, so far we have one employee that was hired prior to January 1st, 2007, which happened to be employee number 28. He or she was hired on June 30th of 2006. Now, let's say we need to look for anyone that was hired on or after January 1st of 2007. This is how you write greater than or equal. And as you can see, all the values here should be greater than or equal to the value that we put in our condition here, or our filter. You should not see anything less than this date in our result sets. I'm going to scroll down all the way down so you will see there is no dates that less than 1/1/2007. There you go. I did scroll over all our 289 rows, and nothing was showing that the date is less than this 1/1/2007. Why? Because we literally specify in our query to only see employees hired on or after this date. Now, let's say we want to look for employees hired within a specific date. In that case, we need to use the operator equal right here. So I'm gonna keep my same query here. I will just say where the hire date equal to January 31st of 2008. And let's say if there is anyone here. Yep, we have one of their VPs that was hired on the same date, actually, January 31st of 2008. Now let's say we need to look for another employee that was hired on January 31st of 2007. Let's see if there are any that exist. Nope. Okay, so I'm trying just random numbers to see if I can come across any employees here. Okay, so we have December the 5th. Okay, so we have one here that was hired on the date that I entered. So this is how you write the equal operator. Now let's go over the plus and the minus operators within our query here for dates. So let's say we want to display today's date. Remember, you always do that by entering get date. And as you can see here, it's giving us today's date. Now, let's say I don't like that format again. I need to only see the date. I don't want to see the timestamp. Okay. So we have today's date. Now, let's say I need to see or ask SQL to tell me what was yesterday's date based on today's date. In this case, I can say get date -1 as yesterday. So if today is January 22nd, yesterday's column should give me January 21st. And let's run it. And as you can see, it's telling me it's January 21st. Now let's say I want to see or find what tomorrow's date is going to be based on today's date. So pretty much you just switch the -1 to +1. Run your query. And as you can see, today's date is January 22nd. Yesterday was January 21st. And tomorrow it will be January 23rd. Why I misspell this. Tomorrow's date. Okay. This is how you run or execute all these operators within SQL statements or queries. The in list allows you to check whether a value matches any values within that in list statement or clause. Let's go over a few examples here to show you how we can use that. Okay, as usual, we need to write our query. Select star from, let's use our employees table still. Okay, so let's just use these columns for now. So let's say I need to only look for employees whose job title is a design engineer. Then I can say where job title equal design engineer. So as you can see, I have 3 employees. Now let's say I need to return a data set related to all employees under the design engineer job title and marketing specialist. In that case, I will need to create my list. And the way I do that is simply by typing where job title in, and this is my list. If I run my query, you will see that the results are returning any employee under the design engineer or the marketing specialist job title, as I specified here in the list. Now let's say I need also to add another value here. So I also need to see anyone that's accountant in addition to these two job titles. Okay, so I have an error here. It's because I forgot to add single quotes to wrap the value here that I'm looking for. All right, so we have employees under design engineer, marketing specialist, and accountant, exactly as we specified it here. We say in our in list, we have design engineer, marketing specialist, and accountant. And that's what you will get once you execute this query. So this is how you run or use an in list within your query. Today we'll be going over the aggregations in SQL Server, and the first function we'll be talking about is sum. The sum function returns the total, net, or sum of a numeric column. Let's go over an example so I can show you how we use the function sum within the query. Okay. Let's start building our query here. Today we're gonna use a different table. It's called sales. Let's see what the sales table has first. So we have an order ID, we have an order date, salesperson ID, store, product ID, product name, quantity of product sold, unit price of product sold, the total price of the product sold, and the territory under which those orders fall under. Now let's say I need to see all the total amount that was sold per year from this table. The way we do that is I need to specify first, use the order date, and I need to turn this order date into a year. Remember from the previous videos, we did actually extract the day, the month, and the year from a date. We will be using the same thing today. Okay, so we will say year, order date, as, and we will call it year. The next thing we will be doing is we will need to net this column here, or sum it. And in order to do that, we have to write sum and the name of the column that we need to actually sum or net. We will call it net paid. I'm sorry, sold. Now, if I run this query, it will give me actually an error message here. it's going to tell me that the order date is invalid in the select list because it is not contained in either an aggregate function or the group by clause. Now, because I'm trying to group by the year, so I can sum or net the total sold for each year, I will need to bring this year from the order date under a group by function, like this. Now, if I run it, it should calculate all the total sold per year. And we will see that down here in the result set. As you can see, in 2013 we sold this much money, or we made this much money in sales. In 2014, same thing, we made this total. 2011 and 2012. Now, as you can see, I don't have my data ordered or sorted by year. What I can do here, I can add an order by at the end, and I can say order by year order date. Once I do that, you guys will see that this data set here will be sorted by the year. So in this case, it should start from 2011 forward. Let's run it. Alright, so as you can see, I have everything sorted in an ascending way. Now, let's say from this query or this data, I need to break down each year by territory. So for example, for 2011, I need to see how much money we sold in total per territory. In order to do that, we will need to use this same query actually, and we can add our additional column. Let me see if we have that column in the table, because it looks like I'm getting an error here. Maybe it's called differently. So let me pull the top 5. It is territory. Oh, I have the column misspelled here, so that's why I didn't recognize it. So it's territory. So let me fix it here so it will show as it's supposed to. Okay, now since I added this column to my select statement, I will need to add it to the group by as well, like this. And I like to separate my items when I write my query, so it's easy for me to read. So these are the items under the select statement. This is my from or source table. This is my group by items, and this will be my order by. Now I don't need this anymore because I just used this query to figure out why I had an error on the territory column. Since I don't need it, let's remove it. Okay, so now let's run this query and I will show you what I meant by the additional breakdown that we added to this query, to the original query. Okay, so now we have, for the year of 2011, we have a breakdown by territory. Each territory has a total of the amount sold for that year. And this is how actually our result will look like. And we will see the same thing for 2012. It will show you the breakdown by territory and the net for each territory. That was the net that was sold. Same thing for 2013. So the breakdown by territory. And it looks like we have some territories outside of the US. We have Germany, Canada, France, Australia, and the UK. Okay. So this is how you use the function sum when you aggregate in SQL Server or in SQL in general. Count. The count function returns the number of rows that matches a specific criteria within a query. Let's go over an example so I can show you how to use the function count within a SQL statement. Okay, let's build our query as usual. And let's use the same training table. Sales. Okay, so now let's say I need to check how many products were sold per year and how much money in total we made for all those totals or total orders or products. In order to do that, I need to extract my year from the order date. Then I need to count the product products. Actually, these product IDs are actually assigned and correspond to certain product names. So I'm just going to count these, how many we had for each year for now. So I can show you guys how we count items within a table. So let's run our query. As you can see, this is the total of products sold for the year 2013. This is the total of products sold for 2014. This is the total sold for 2011, and so on. Now, let's say I need to add the sum of the total amounts sold within each year. In order to do that, I'll just add sum to my query here. Hopefully that's the name of the table that we have. Let me run it first. Yep, it looks like it's okay. So now I've got the total of products sold and total money we made out of those sales for each year. So again, my data is not sorted. Let's sort it. I have to add an order by. Let's name it the same way we named it within our query, so the query won't get confused. Alright, so now we have the data sorted in an ascending way. and it's actually bringing us exactly what we were asking for. So this is how we aggregate using a count and sum all at the same time. Min. The min function returns the smallest value of a selected column based on the criteria that we will specify within our query. Let's go over some examples here, and I will show you how to use the min function within your query. It's still part of aggregations, because when you use min, you still have to use the group by. Let's use our sales table still. Okay, and let's say I need to see for each year when was the very first day an order started or was sold. In order to do that, we need to extract the year from our order date, and we can type in our function min. So we need the min order date, and we can alias it as min order date. Now this is my from, and right after my from, I will need to specify my group by. And when I group by, I have to group by the column that I'm using for the breakdown, which is the year. Now let's run this query so we can see how the data will look like. Alright, so in the year of 2013, the very first day an order was sold was on January 28. In 2014, the very first day an order was sold was January 28. So it looks like it's the same, around the same time between 2013 and 2014. Now in 2011, the first day an order was sold was May 31st, and in 2012 it was on January actually 1st when the first order was sold. Now the same thing, let's see how we can order our data. So I'm gonna use the year to order actually my data. Okay. Now, since we returned the min date an order was sold, let's bring in also do a count of how many products were sold during the year of from 2011 through 2014. So let's see here, let's call it products sold. So for each year, this is the very first day an order was sold, and this is the total of all orders sold within that year. Let's see how now let's net how much money we sold per year. So I'm doing this in purpose for every function that we are going over. I'm trying to repeat previous functions that we saw in different sections of this tutorial, just so I can refresh your memory about how to write them. Alrighty, now let's run this query here. And as you can see, we have our year, which we are using to break down all those these summaries. Here we have the minimum date an order was sold. Over here under product sold is the total count of all the orders sold for that year, and this is the net of money that we collected from all those sales per year. So this is how we use the min function. Max. The max function returns the largest value of a selected column based on the criteria or condition that we will write within our SQL statement. Let's go over one of the examples so I can show you how we use the max. Let's build our query. Let's use the same sales table. And let's return. What we will be doing is we will break down the cells, and we will be looking for the max date an order was actually placed for each year within the sales database or table, sorry. Okay, so we have year, order date, and let's alias it as year. So there is something that I just did here. This actually word or column name was written in lowercase, and just there's a shortcut on the keyboard that you can use in the event that you don't want to see it that way. You want to have it in uppercase. You don't want to rewrite it because that's gonna waste some time. What you can do is highlight it and do Control Shift and U on the keyboard, and it will automatically switch it from lowercase to uppercase. I like to write my code in uppercase because it actually makes it easy for me to read. So the next one, let's do our max here. Max order date. Now that we built our select statement, we will need our group by. Since we are doing the breakdown by the year, I will need to specify it in the group by. Because if you don't specify it, as I showed you last time, the code will error. Now, if I run it with the group by, it should give me the max date for each year. So let's use our order by. Now, this will give me the max date an order was sold for each year. Let's implement the min all along within this data here, or this query. And let's run our query. As you can see, in 2011, the very first date an order was sold was May 31st of 2011, and the last day of the year when an order was sold for 2011 is December 1st of 2011. And the same thing here for 2012. The first day we made a sale was on January 1st of 2012, and the last day we made a sale in 2012, it was in December 31st, as you can see here. Now let's add the count of products sold for each year. Product ID. Yep. And this will give us the total for each year of how many products we sold. And now let's do the sum of all the money we collected from our sales for each year. And let's call it net sold. And as you can see, in my aggregation here, I had the minimum date an order was sold for each year, and I returned the max date an order was sold for each year again, and the total or count of each of all products sold within that year, and the net of all money we made or collected from all those sales per year again. This is how we write our max function, and this is how we aggregate in SQL. Having. The having clause is used actually in SQL due to the fact that the where clause cannot be used within an aggregate function. Let me show you how. Let's build our query. Let's use our training sales table still. So let's say I need to count, or actually I need to know how many orders in total, or how many products in total were sold per territory. Let's do that. And we will need to sum our quantity column here. And we will alias it as total quantity. Now let's group by our territory column, and let's execute our SQL statement. Now we actually received some data in return here, where for each actually territory we received the total of quantity of those orders that were sold. Now let's see how we can implement the having within aggregation, because again, just to as a reminder, we can't use the where clause in this case when we use the aggregation, because if I use, for example, where, let's say, quantity equal, let me pick a number here, or greater than, let's say, what's the biggest number here? Okay, so we have million and we have some that are under million, like these. Okay, so let's do 1 million. Okay, now if I run this, I may not even get anything. And why? Can someone tell me why? If you know the answer, please make sure to write it in the comments of this video, and I will reply to you and let you know if you got it right or not. Let me tell you why. because we are trying to get a sum in here. I'm going to comment out the where clause and I'm going to rerun my query. So when I did this aggregation, you would think that at least these rows here that are above 1 million should be returned, right? But actually, if you put a where clause, you are targeting the unique actually rows within that table, and there is no way you can find a row that has 1 million products sold for that day, because this aggregation here was actually an aggregation to bring a summary of all orders sold for all those years that exist within that table, not just each order actually. Because as you can see, the total quantity is super low for each row, so there is no way we're going to find something that has 1 million actually in quantity. And let me run the whole table for you, just so I can show you. So here is our quantity column. I'm going to scroll down and you will see that all the numbers here are super low compared to the number million. So this is actually, we can use this at the order level or the date level. But when it comes to aggregating the whole table and every single row within that table, we can be using this where clause. In this case, if I need to return anything that's above 1 million, I will need to add a having. What having will do, it will actually calculate this data and put it in the temporary in the memory of the server. Then it will give us anything where the total of quantity, this column here, is greater than 1 million. So this data that I have here, and we have like 10 rows. This is the total of all products sold by territory across the whole table, no date limitation. Now I'm going to try to return out of all results from this query here, I'm going to return only rows where the total quantity column is greater than 1 million. Let's try that. So instead of the 10 rows, let's see how many we will get back in return. Okay, so we only got 5 because only 5 regions did have a total actually quantity over 1 million. The other ones, they had less than, I'm going to switch the operator to less than 1 million so we can see the other territories. Okay, so Germany, UK, France, Northwest, they all had a total of sales or products that is lower than 1 million. So this is how we use the having function or clause within a SQL statement.